Hey guys, Mr. Middleton here. Today we're going to talk about radical equations. At the end of this video, you should be able to solve radical equations, and you should be able to determine when a radical equation has no solutions. Okay, a radical equation is an equation that has a variable inside the radical. Okay, make sure it's inside the radical. So which of the following is not a radical equation? Well, looking at it, I can see that B is not a radical equation. This is not a radical equation because although it has a radical in it, it does not have the variable underneath the radical. Okay. To solve a radical equation, you must first get the radical expression by itself on one side of the equal sign. Okay? So let's look at this. Alright, what is the radical expression for each of the following radical equations? Well, here for the first one, A, we're talking about just the thing underneath the radical. So the radical expression for the first one is just radical x. Okay? For the second, we're talking about all the stuff underneath the radical. Second one will be radical 3x minus 5. In both these problems, to solve it, we need to get that by itself before, that should be our first step. Hey, to get these radical expressions by themselves, we need to move the numbers on the outside of the radical to the other side of the equal sign, just like when we're solving an equation. Okay? So get the radical equations above ready to solve by getting each radical expression by itself. Alright, so for A, we'd have 3 radical x plus 8 equals 20. Well, the first thing that we would do is we would subtract 8 from both sides. Okay, just like if we were trying to solve for, I guess, x by itself. And then, finally, to get that radical by itself, we would divide both sides by 3. And so then radical x would equal 4. Alright, now, same thing with the second one for B. We have to radical 3x minus 5 plus 1 equals 15. So the first step is we're going to subtract 1. So we get 2 radical 3x minus 5 equals 14. And then we divide by 2. And so we'd have radical 3x minus 5 equals 7. Alright, once you do this, you're still not done with the problem because we don't have the variable by itself yet. But now we can get rid of the radical. How do we get rid of a radical? We square it. Square. We're going to square both sides of the equation. So when we square both sides of the equation, remember what happens is, since squaring is the inverse of square rooting, it cancels out that operation. So on our left side, we're left with x. On our right side, we're left with 16. Okay. Now in the second equation, we have 3x minus 5 equals 7. Once we square this one, on our left side, we're left with 3x minus 5. And on our right side, we're left with 49. So we're not quite done with this one yet. We still need to continue to solve it. We'll add 5 to both sides. That'll give us 3x equals 54. Divide by 3, and that will give us x equals 18. Alright. Let's try some more. Alright, we'll do a few together here. So we have radical x plus 7 equals 12. We're going to get the radical by itself. So we're going to subtract 7 from both sides. Gives me radical x equals 5. I need to get x all the way by itself, so I square both sides. And once I do that, I get x equals 25. Number 2. First, I need to get rid of all the numbers outside of the radical. So radical 2x, after I divide it by 3, equals 4. Square both sides, I get 2x equals 16. And now divide by 2, x will equal 8. Number 3, There's nothing outside this radical now, so I can square right away. So 2x minus 3 will equal 49. I'll add 3 to both sides to get 2x. The x is closer to being by itself. Divide by 2, and x equals 26. Number 4, I will first subtract 5. So I have 3 radical x plus 4 equals 12. Then I'll divide by 3 to get the radical by itself all the way. X plus 4 equals 4. And then I'll square both sides. And so x plus 4 will equal 16. Okay. Now to solve for x all the way, I'll subtract 4 from both sides, and that gives me x equals 12. Number 5, add 7 to both sides. And so I get radical 5x plus 3 equals 3. Now I have that radical by itself, so I can square the sides. So now I have 5x plus 3 equals 9. I'll subtract 3 from both sides, so 5x equals 6. And then I'll solve by dividing both sides by 5. Now, I'm not going to make this super complicated. 6 over 5. That's my answer. Okay, you could use it as, you could write a decimal of 1.2, but 6 over 5 is a little bit neater and a little bit faster to do. Alright, number 6. I'm going to add 1 to both sides, so I have 5 radical 3x over 4 equals 15. Then I need to get this radical by itself, so I'll divide by 5 because 5 is multiplying. So radical 3x over 4 equals 3. And now I'll square both sides. Running out of space here, so I'm going to move up. So I have 3x over 4 equals 9. And now I just need to solve this problem. I'll multiply both sides by 4. That gives me 3x equals 36. Divide by 3. And that will give me x equals 12. Alright, bunch of problems there. Same process each time. Get the radical by itself, square both sides, solve. Alright, the next one is tricky. We have radical x plus 8 equals 5. Okay, when you get the radical by itself, what number does it equal? Well, we're going to subtract 8 from both sides, and we'll get radical x equals negative 3. Okay, can you take the square root of any number and get that number? And the answer is no. Okay, nothing times itself gives you a negative number. 2 times 2 is 4. Negative 2 times negative 2 is 4. Notice that if you multiply a number by itself, it's going to be positive. So you can't multiply to get a negative number. Therefore, this problem has no solution. Okay, once you get a radical expression by itself, you must check for this. If there's no solution, make sure you write no solution. Okay, so again, you can try it, you can pause it and try it if you want, if you'd like, and then catch up with me, or you can follow along with me. Okay, I'm going to add 7 to both sides. Start off negative. We have radical 4x equals 2. I'll square both sides, so I have 4x equals 4. Then I'll divide by 4, x equals 1. Okay, works out. This problem, we have a negative at the beginning, but don't let that fool you. Just go through the process. Okay, don't have to look for shortcuts because the process isn't that bad by itself. Radical equals a positive number. That works. So x plus 1 equals 49. Subtract 1 from both sides. X equals 48. Number 3, I'm going to subtract 6 from both sides. Negative 2. Radical 2x minus 5 equals 10. Then I'll divide by negative 2, and I get radical 2x minus 5 equals negative 5. Okay, now I can see I have a radical equaling a negative number. Right there I can say no solution. I don't need to go any further. In fact, if I square both sides, I get a positive number, so I need to be able to recognize it at this step. Okay, you need to be able to recognize it at that step. Alright, some kind of tough problems down here. We have radical 3x plus 4 equals radical 5x minus 6. Now, if we have a radical on both sides, there's not really a way that we're going to get the radical by itself. So what we're going to do, I guess we ask ourselves, is the radical by itself on this side? Is the radical by itself on this side? If the answer is yes, then we can square it. 3x plus 4 equals 5x minus 6. And now we can solve for x, just like a variable with both, an equation with variables on both sides. So subtract 3x from both sides. I'll add 6 to both sides in the same step to save some space. So cancels out here, gives me 10. Gives me 2x, cancels out here. So 2x equals 10. That means x will equal 5. Number 5, I'm going to subtract 8 from both sides. I get negative radical 2n equals 12. Divide by this negative 1 because it's not by itself yet. And so I have radical 2n equals negative 12. Right there, I can tell that there's going to be no solution. Okay? There's no way I can solve a problem because it won't ever come out to be that way. Okay? Now, number 6, we have radical x plus 10 equals radical 6 minus x. Again, are the radical expressions by themselves? Yes. So we can square both sides. We have x plus 10 equals radical 6 minus x. Equals 6 minus x. We squared that side, so that's gone. And so now we can just solve this problem. I'll rewrite it because I don't want anybody to be confused by that. Okay. And now we can just solve this problem. Get the x's together, so I'm going to add x to both sides here. And because I know my x's are going to be there, I'm going to subtract 10 from both sides. So I get 2x equals negative 4. Now, is it okay for 2x to equal negative 4? Yes, there's no radical here. Remember, our radicals can equal negative numbers, but our variables could. It works out that way. Divide by 2, we get x equals negative 2. Okay? And so if we plugged it back in, we have negative 2 plus 10, which gives us 8. And we'd have 6 minus negative 2, or 6 plus 2, which gives us 8. Radical 8 equals radical 8. It works out. Okay, so we went through a bunch of examples here. The gist of it is make sure you get the radical expression by itself and then square both sides to solve. All right, see it.